Alright, real quick video on speed of light, calculating it, and a couple sample problems. Speed of light is a universal constant. In our formulas it will always be the same. Constant means staying the same, so that's good. And always is in all caps, because as far as we're concerned it will never ever change for this class. It'll always be 3.0 e to the 8th meters per second. That's 300 million meters per second. As you can see, scientific notation is a little faster this way, but to each their own. Sometimes you'll also see it as kilometers per second, but we're going to stick with this. Now, since it's constant, for that symbol, we're going to use C. C for constant. Crazy, right? So our symbol is going to be C. Now, our formula for calculating wavelength and frequency is going to be C, constant, equals lambda times F. Now, C was our constant. Lambda is wavelength. Wavelengths. Wavelength. And F is frequency. Oops. Help if I could spell correctly. Frequency. There we go. Okay, from the other video you should remember our symbol for wavelength is meters, and for frequency is hertz. Okay, so we're going to use that formula we just did, and we're going to do a few examples of calculating wavelength from the speed of light. So we're going to say we have constant equals wavelength times frequency. Constant never changes, so 3.0 e to the 8th meters per second equals, we're calculating wavelength, so we're going to say we don't know it, times our frequency. And let's just make one up. 1.5 e to the 6th hertz, just to keep it simple. And then from here it becomes a simple algebra problem. So we want lambda by itself, so divide to cancel out 0.5 e to the 6th hertz. Now it's an equation, so what you do to one side you have to do to the other. 1.5 e to the 6th hertz. Now over here the whole thing cancels, so this just ends up as 1, so we end up with just lambda. Now I haven't mentioned it, but the hertz represents 1 over 1 second. Sometimes you'll see it as s to the negative 1. I won't show you guys this, but just saying. So the 1 over the s, so when we're dividing by 1 over s, we're really multiplying by s over 1, so that cancels out the seconds. We're left with just meters. And then from there, we just divide. I'm not going to lie, I can't do this in my head for the most part. I picked an easy one that we can do in the head. You should be using your calculator for this, but we're going to do it simple. 3 divided by 1.5 gives us 2.0, and then e to the 8th divided by e to the 6th is e squared. And what are we left with? Meters. So 2.0 e squared is our meters, is our wavelength. That's how you calculate wavelength. We'll do one more example. Nice and clean. This one we're going to put a pause into so you can try to solve it on your own before I just show you. Again, constant never changes, so we're going to say 3.0 e to the 8th meters per second equals an unknown wavelength times, let's say, 6.0 e to the negative 2 hertz. Now we're going to pause. Also, I'm going to dig out my calculator, so because I can't do this one in my brain. Alright, we're going to give it a couple seconds here. Pause the video if you want to try to solve it on your own, or we'll just jump right into it in just a few seconds. Okay, here we go. So again, we want lambda by itself, so we divide both sides by our frequency. It's an equation, so it has to be both sides. 6.0 e to the negative 2 hertz. And this whole thing cancels out, so we're left with just lambda equals, and then 3.0 e to the 8th divided by, whoops, cancel those first, divided by 6.0 e to the negative 2 gives us 5.0 e to the 9th meters. So you have to include your unit. 5.0 e to the 9th is not a length, it's not a wavelength. It has to have your meters in there. That's our lambda. It was running kind of long, so we're only going to do one frequency example, but it's the exact same process we just did for finding a wavelength. We're just changing our units. So, whoops, constant never changes, 3.0 e to the 8th meters per second equals, this time we're going to pick a wavelength, let's say 2.5 e to the 4th meters times an unknown frequency. Exact same process. Divide by 2.5 e to the 4th meters. Oops. 2.5 e to the 4th cancels 2.5 e to the 4th. Meters cancel meters. Now we do the same thing on this side. 2.5 e to the 8th meters. Meters and meters cancel. Oh, whoops, not e to the 8th. That should be e to the 4th. That was my mistake. E to the 4th. Okay, take a few seconds, solve this one. I'm going to pause it. It's been a few seconds. You plug this into your calculator, you end up with 1.2 e to the 4th. And then our unit is 1 over 1 second, which from earlier, you should remember 1 over 1 second equals 1 hertz. So our unit for frequency, hertz. So in this case, our frequency works out to 1.2 e to the 4th hertz.